Hello, everybody. I hope you guys had a great Memorial, Day weekend, and that you guys are relaxing and well rested, and that your tests, I think they should be all done. I think I'm going to double check the due date on that. So this week we have 2 days of class left. I considered being a terrible person and giving you a final exam and having a review day today and then your final exam on Thursday, but that's just mean. So I'm not doing that to you. Instead, we were reviewing also because we just took like 2 tests in a row. I'm not going to do that to you. We'll count the last one as the final exam. So today, what we're going to be doing is we're going to go back over some exponent properties of exponential and logarithmic functions, and we're going to do some solving. So you guys should have done the properties activity with the solutions in the first activity. I guess the second, if you don't include the warm-up, or do include the warm-up. And then we will be doing this together now, and then you have a cognitive practice that you'll do. All right, so let's go ahead and get started. So we're solving exponential equations. So there's some like scenarios that can happen. The first scenario is when, also note this is exponential. Okay, we're not doing logarithmic yet. So the first scenario is when our bases match. Okay, so here it appears that our bases do not match because I have a 5 and a 25 as my base. But I can rewrite that 25 so that it does have base 5. So I'm going to rewrite that whole equation. 4x plus 2 equals, now 25 is just 5 squared, so I can rewrite it as 5 to the 2 times x minus 3. Okay. Now they have the same base. When they have the same base, I can just set the exponents equal to each other. Okay. I probably should have gone ahead and simplified, but I will do that now. So we have 4x plus 2 equals 2x. Why do I do this to myself? 2x minus 6. Subtract 2 from both sides to get 2x on the left. Subtract 2 on both sides to get negative 8 on the right. Divide by 2 to get that x equals negative 4. Okay. All right. Now 3 to the 2x and then 81. So we have 3 to the 2x. That's the simpler base. There's not as much we can do with that. Notice, though, that if you're confused about like 81 and 3, 81 doesn't seem like maybe it would be divisible by 3. I believe there's a property where you can add the digits, and then if that number is divisible by 3, then the number is divisible by 3. So 8 plus 1 is 9. 9 is divisible by 3, so that does work. But you could see here, if you were maybe confused, 3 to the 2x is really like 3 squared to the x, which is 9 to the x, and 9 is definitely a factor of 81, so maybe you can see it that way. But I'm going to keep the left-hand side as simple as possible, and then on the right-hand side, I'm going to rewrite that as 3 to the 4th, okay? 3 times 3 is 9, so if you have 2 pairs of that, and then multiply those together, the 9s give you 81. That's 4 3s in total. This means that 2x is equal to 4. Divide by 2 on both sides, and we get that x is equal to 2. Okay. Then I want you guys to go ahead and try this one on your own. I'll obviously post solutions so you'll see what it is. Now, we also can do this when the bases are not the same, okay? This isn't impossible. So what we want to do in this case is we want to rewrite it in terms of a logarithm. This should be in your formula packet. Let me pull it up. My pen got stuck. to the bottom of the formula packet and I was pulling it up. Okay, so if you go into your formula packet, oops, I think I passed it. And it's in this topic 1 section. We have exponential and logarithmic transformations, like going back and forth between the two not methods, but forms. And so we have 6 to the x equals 49 here. We can rewrite that. And there are 2 ways to think about this. You can think about it in terms of this and just rewrite the variables in their correct places. So this exponent becomes the answer right here. The log has the same base, and then the b that was on the other side of the equal side goes inside of the log. Or you can think of it as taking the log base 6 of both sides. So I kind of like to think of it that way. So because it's hard for me to remember a whole formula. Okay, so log base 6 and 6 to the x, the exponential functions, are inverses of each other. So they cancel out, leaving just x equals log base 6 of 49. Okay, so all I did was take the log base 6 of both sides. I chose log base 6 because the exponential function had a base of 6. And you just do it to both sides. They cancel out on the left, leaving x, and then you get log base 6 of 49 on the right. That's it. And you can leave it like that unless it tells you to put it in decimal form. Over here, I would take log base 5 of both sides. So log base 5 of 5 to the 2x equals log base 5 of 8. Okay, so I would be left with 2x on the left, and then I would have log base 5 of 8 on the right. Okay, and then I can just divide by 2. Okay, this isn't going to be able to simplify because 5 and 8 don't have common factors. So x is equal to log base 5 of 8 over 2. That's it. I guess I should be boxing in my solutions. Oops. Okay, and then you guys try the last one, and then you can look at the solution when I post it at the bottom. Okay, so then at the bottom we have examples where x is on both sides of the equation. Okay, so what we're going to do here is we're going to rewrite these in terms of logarithm